In the past, we've used tables to represent quadratic functions. In this video, we're going to take that concept. Well, first we'll take it one step further and graph using those tables. And then we'll talk about some patterns that emerge in quadratic functions. So let me show you something that you might see. F of x equals 2 times x minus 1 squared plus 3. I don't know. And you might see this. Notice that we've got a square here, right? So we know it's a quadratic. And you could do this, right? In the past, if you've ever graphed or used a table to solve a quadratic, used a table to represent a quadratic function, then we can do this using a table. And like I said, we're going to take it one step further and graph. Now, how do you know which points to choose? Well, let's just say we don't know, and let's try some things, right? So, and maybe that. Let's just try a few things, okay? So here we have x, here we have f of x, and here I have my function 2 times x minus 1 plus 3. Let's start at -2 and go to +2, and that should give us at least some idea of where to start. I'm just kind of running the middle 5 numbers of my graph to see where I'm at. Okay, so this is 2 times -2 minus 1 squared plus 3. -2 minus 1 is -3. -3 squared is 9. 2 times 9 is 18. 18 plus 3 is 21. Wow. Okay, that doesn't even fit on my graph. So let's try the next number, -1. And generally, a good rule of thumb is if at -1 I start decreasing, I'm probably headed in the right direction. If I start increasing and I'm getting even bigger numbers that aren't going to fit on my graph, I might be headed in the wrong direction. Okay, so -1, 2 times -1, minus 1 squared plus 3. Okay, -1 minus 1 is -2. -2 squared is 4. 2 times 4 is 8. 8 plus 3 is 11. So that's not too bad because -1, 11 is like 6, 7, 8, 9, 10 is like somewhere up here, right? Kind of hard to find, but it's just right kind of past our graph. All right, let's try 0. 0 is 2 times 0 minus 1 squared plus 3. 0 minus 1 is -1. -1 squared is +1. 2 times 1 is 2. And 2 plus 3 is 5. Now we've got a number we can work with. That feels really good. Okay, again, we've got 2 more. So at 1, 2 times 1 minus 1 squared plus 3. 1 minus 1 is 0. 0 squared is 0. 2 times 0 is 0. And 0 plus 3 is 3. So at the point 1, we have 3. Now maybe even think, is there a pattern? Even there, looking at our original equation and looking at the point that we just had. Okay, let's look at the next point. 2 minus 1 squared, that's 2, that should be 1. 2 minus 1 squared plus 3. 2 minus 1 is 1. 1 squared is 1. 2 times 1 is 2. 2 plus 3 is 5. Again, do you notice any patterns? We have this point 2, 5 right here. And now it's kind of hard to draw. Not an expert at drawing quadratics, especially on my tablet, but we'll try. It's hard to keep track of exactly where the mouse is. Something like that. That's about what our quadratic function would look like. And again, if you have a tool like IXL or even a graphing calculator, that makes this a lot easier to see the shape. But quadratics, as we know, usually have this U shape, so connecting the point, we kind of U it out. So that's that. That's one way that you could solve this equation. Now, here's some things that I want to point out to you. Notice that up here, I had 1 and 3, and then when I put in the point 1, I ended up with 3. That's interesting. Also notice that on either side of this point, when I had 0, I got 5. That's 1 to the left of this turning point. And then when I had 2, 1 to the right, I also got 5. So what do we call this point right here, this 1, 3 point? If you remember, it's called the vertex. And what's pretty cool is we have 1 point to the left of the vertex is mirrored exactly over to the right of the vertex. Remember, that's the line of symmetry, is that my parabola is actually symmetrical. So could I use a few tricks to make graphing this much, much easier? Absolutely, I could. Let's try it out. Let's use the same equation and talk about properties of quadratics and something we call vertex form to make graphing a little bit easier. What do we say? 2x minus 1 plus 3, x minus 1 squared. Okay, so I know that my vertex is at this point here, and we have something called vertex form when it comes to quadratics. That's a times x minus h squared plus k. Okay, and that's a lot of stuff, but here's what you need to know. H comma k, that point is the vertex like we just saw. So here, my vertex is 1 comma 3. Notice it's minus h. So if I have minus 1, it's positive 1. If I had plus 1, it would be negative 1. So my vertex then is at 1, 3. Look, I didn't have to do any calculations, and I was already able to find something out. Okay, now what about A? What about A? A, it does two things. It scales the quadratic, and it tells us whether it opens up or down. If it's positive, it opens up. If it's negative, it opens down. If it's negative, it opens down. Okay, so it changes how narrow, maybe we would say this changes how narrow, not marrow, narrow, wide my graph is. Okay, so you know vertex form and you found this vertex, but how do you graph it? What's another point that you could use? Well, what I like to do is just take one point to either the left or the right of my function. Now I like, so you can say, oh, well, this is 0 or 2. Doesn't really matter which one you want to use. Let's use 0. And we saw in the last, we saw what we just did, right? F of 0 is 5. F of 2 is 5. So you could choose either point to the left or to the right. So then I would substitute in 0. 2 times 0 minus 1 squared plus 3. That's negative 1 squared. We already did this, right? 2 times 1 is 2. 2 plus 3 is 5. So at 0, my point is 5. Now, where the vertex is, remember, that's also where the axis of symmetry is. So, right, I can reflect my point across the axis of symmetry. Here, it's at 5. It's 1 away from the axis of symmetry. So I come over here, oops, and I can draw another point. Now remember, we had that other point that was up here at negative 1. Oops. It was up here at negative 1, comma 11. You could also reflect that. Go 1, 2, 1, 2. Right? And that will work every time. Man, it is so hard to draw a parabola. It's the little things, you know? Okay, that's close enough. So, yeah, so if you know vertex form, then you can make that happen. And I would say that those are the key things that you need to know, right? You can use a table and just find the vertex, find that turning point, and you'll be off to the races, right? You can plug in as many values as you want to find that. Or you can use vertex form to your advantage. Now let's do one more. Sorry, my lights kind of pop on and off. Just one quick thing I want to show you. If you have a function like this, if you have a function like this, you're like, Mr. Dussault, this doesn't look like vertex form. Okay, well, I could rewrite it like this: -2 times x minus 0 squared plus 0, right? Because if we were to simplify this, x minus 0 is x. Anything plus 0 is just itself, so that would be -2x squared. Okay, so if you ever see anything like this, you should know the vertex is going to be at the origin. So just use a point like 1. I would say x is 1 point to the right of my vertex. -2 times 1 squared. Remember, square it first. 1 squared is 1. -2 times 1 is -2. And then at the point where at x is 1, y is -2, we can reflect across the axis of symmetry. And look, I've got 3 points, which is enough to make a graph. And you could keep going if you wanted to find more points, of course, but that's a kind of a quick and simple way to think about that. Okay, so that's that. Use tables to your advantage to graph these. But remember, with vertex form, we have kind of all of this alphabet soup. A times x minus h squared plus k. That's a function in vertex form, where hk is the vertex. A tells you how wide or narrow your function is. It also tells you whether it opens up or down. You can use vertex form to find the vertex and then just go 1 point to the right or to the left to graph the rest of your equation. That's it for vertex form. I'll see you next time.